There is no honor too great to pay to the memory of Micheal Faraday, one of the greatest scientific discoverers of all time. Ernest Rutherford, 1931. You might not think that one could discover, learn, and teach real physics and chemistry with poetry and kindness, but that's probably because you don't know enough about my favorite scientist of all time, Micheal Faraday. Now, Faraday had a severe math phobia that kept him from writing a single equation, but despite this, became the founder of modern chemistry and physics. Don't believe me? Well, I don't know much about chemistry or the action and reaction of chemicals, but I'm pretty sure it uses cations, anions, and ions, electrolytes, and anodes and cathodes. All just a few of the terms and concepts coined by Faraday with help from linguists. How about my favorite subject of physics, or the action and reaction of physical objects, from subatomic particles to galaxies, including heat, gravity, quantum mechanics, optics, energy, electricity, magnetism, and light. Can you imagine physics without the concept that permanent magnets and electromagnets, coils of wire with current in them, emit and absorb magnetic lines of force, or magnetic field lines, that you could see with iron filings? Can you imagine physics without the idea that if these lines of force are broken by a separate coil, it would induce current in the coil, magnetoelectric induction? Or that positive charges emanate electric field lines and negative charges absorb them? Or that conductors have free charges that move to negate that electric field, as demonstrated by this delightful 1960s video?
Today, the present director, Sir Lawrence Bragg, he is giving one of a series of lectures to school children, which were inaugurated by Micheal Faraday. A Wimshurst machine, this giant one was built by Wimshurst himself, is being used to charge a wire cage. It's known as Faraday's bird cage. Strands of silk are forced away from the cage, but the charge has no effect at all on the girl inside.
Or that the charges in insulators adjust to reduce the electric field by their dielectric constant. Or that light is a vibration of these magnetic and electric lines of force, and you don't need an invisible weightless ether for the propagation of light. Or that all materials are magnetic, either strongly like iron, ferromagnetic, or weakly attractive, paramagnetic, or weakly repelling, diamagnetic, all Faraday. How about Maxwell's equations, which led directly to Hertz's discovery of radio waves, and to J.J. Thomson's discovery of the electron, and to Lorentz's relativity, and to Einstein's relativity and Einstein's equals mc squared, and to Oliver Heaviside's work, and to Charles Proteus Steinmetz's electrical engineering rules called phasors, which are the main tools that electrical engineers use to this day, and so much more. Well, according to Maxwell himself in the introduction to his 1873 magnum opus, quote, "If anything I have here written may assist any student in understanding Faraday's mode of thought and expression, I shall regard it as the accomplishment of one of my principal aims, to communicate to others the same delight which I have found myself in reading Faraday's researches." Personally, the only reason I could manage to get through Maxwell's papers and his book is because I took the time to first go through many of the papers of Faraday, as well as the papers of Coulomb's, Ohm's, Lenz's, Ampere's, and Hamilton's papers. Trying to read Maxwell's book without all of that preamble is nearly impossible, I think. That is why my video where I derive Maxwell's equations from basic concepts has a bit about the history, as without it the subject takes weeks to comprehend and teach rather than 33 minutes. But that isn't all. Faraday was also a slam poet. Well over 100 years before Mark Smith popularized the art form in 1984. Smith described his motivation as the following: the very word poetry repels people. Why is that? Because of what schools have done to it. The slam gives it back to the people. We need people to talk poetry to each other. That is how we communicate our values, our hearts, the things we have learned that make us who we are. In other words, slam poetry is talk poetry, where you say your sentences without rhyming or iambic pentameter or any of the rules of poetry, but it still feels poetic. Faraday described it as the following: I am no poet, but if you think for yourselves as I proceed, the facts will form a poem in your mind. Isn't that delicious? If you think for yourselves, The facts will form a poem in your mind. Faraday's poetry was so strong that after he gave a single lecture to teens in 1848, it inspired none other than Charles Dickens to write to him.
Here we have two letters from the Micheal Faraday correspondence collection, and these are from Charles Dickens, the great Victorian novelist. In these letters, Charles Dickens is asking Micheal Faraday if he could borrow his lecture notes on the chemical history of a candle, which was the lecture he gave at the Royal Institution in 1848. Charles Dickens is a big fan of Micheal Faraday and would like to publish his works in his Household Words magazine. At the end of this letter, Dickens writes, "Pray let me add, as one who has long respected you and strongly felt the obligation society owes to you, that the day on which I took the liberty of writing to you will always be a memorable day in my calendar."
Dickens then took Faraday's notes and put it in his magazine so that everyone could learn his families. He ended up writing a whole series of short plays about it, which inspired the popular science movement. In fact, it was only after World War II when we decided to focus on pushing math and physics to win the space race, that we seem to have forgotten that Faraday was the GOAT, greatest of all time, as he had no math. And we switched to teaching physics as if we could just pry people's heads open and pour in the facts with dry math. You might be wondering how Faraday did all this, and that has to do with his history. See, Faraday was born in the slums of London to parents who were strong believers in a type of Christianity called the Sandinistas. This religion was kind of like the Quakers, and each adult male and female was considered an equal part of the church with their own relationship to the divine. Due to their religion, the vast majority of their members could read, which wasn't so common at the time, especially for women. Despite their extreme poverty, Faraday's parents collected enough money for both Faraday's big brother Robert and him to go to a decent school. However, after a week at this decent school, Faraday's teacher decided to beat Micheal for calling his brother Wobert instead of Robert, and to emphasize the punishment, gave his 9-year-old brother Robert a halfpenny to buy a cane for a proper whipping. Instead, Robert threw away the money and told their mother of it. She immediately took both kids out of school, and all the children were left with the rudimentary schooling that only taught reading, writing, and basic arithmetic. From then on, the family taught each other what they could with what meager resources they could find. And Faraday was encouraged to learn from everything he saw and everything he experienced. As a young teen, he used to hang out at the business of a bookseller and binder named Mr. Rabau. Rabau took a shine to Faraday and hired him to deliver books and newspapers. Soon, Rabau offered to let Faraday learn how to be a bookbinder for free. Not only that, but Rabau allowed Faraday to have a little corner of the bookseller's shop to do little experiments in. Rabau recalled, "Faraday was always searching for some mineral or vegetable curiosity, his mind ever engaged." It was at this job that Faraday read a textbook for young girls called Conversations on Chemistry by a woman named Jane Marcet. Years later, he recalled, "Do not suppose that I was a very deep thinker or was marked as a precocious person. I was a very lively, imaginative person and could believe in the Arabian Nights as easily as in the encyclopedia. But facts were important to me and saved me. I could trust a fact and always cross-examine an assertion. So when I questioned Mrs. Marcet's book by such little experiments as I could find means to perform, and found it true to the facts as I could understand them, I felt I had got hold of an anchor in chemical knowledge and clung fast to it." Then, due to a series of coincidences, Faraday ended up working as a glass washer for a famous chemist named Sir Humphrey Davy. Almost immediately, Faraday skyrocketed to be Davy's right-hand man, and eventually became an independent researcher in chemistry and physics, and the rest is history. You might think that Faraday would discount the impact of Mrs. Jane Marcet's little chemistry book, but that is not the case. Many years later, he wrote a friend that he had a deep veneration for Mrs. Marcet, first as one who had conferred great personal good and pleasure on me, and then as one able to convey the truth and principle of those boundless fields of knowledge which concern the natural things, to the young, untaught, and inquiring mind. You may imagine my delight when I came to know Mrs. Marcet personally, how often I cast my thoughts backwards, delighting to connect the past and the present, How often when sending a paper to her as a thank offering, I thought of my first instructress. I love that term thank offering. Isn't it beautiful? Now I want to read to you a bit about what Faraday thought about the importance of education, which begins, what is the kind of education that science offers man? Note that considering his veneration of Mrs. Marcet and other comments on women, I'm pretty sure Faraday uses the term man and men the way we use male, man, and human. Not to be prejudiced against women, but just because we're so used to the term that we don't think about it. Anyway, this is a long one, but I think it's worth it, so I'm going to repeat most of it. What is the kind of education that science offers man? It teaches us to be neglectful of nothing, not to despise the small beginnings. They proceed of necessity all great things. Festivals make clouds, and they are trifles light as air, but then they make drops, and drops make showers. Rain makes torrents and rivers, and they can alter the face of a country. It teaches us first by tutors and books to learn that which is already known to others, and then by the light and methods which belong to science to learn for ourselves and for others, so making a fruitful return to man in the future for that which we have obtained from men in the past. The scientific student ought not to be as the ant who gathers merely, nor the spider who spins from her bowels, but rather as the bee who both gathers and produces. Electricity is often called wonderful, beautiful, but is so only in common with the other forces of nature. The beauty of electricity or of any other force is not that the power is mysterious, but that it is under law, and that the taught intellect can even now govern it largely. The human mind is placed above, not beneath it, and is such a point of view that the mental education afforded by science is rendered supereminent in dignity, in practical application and utility, for by enabling the mind to apply the natural power through law, it conveys the gifts of God to man. In Faraday's time, the telegraph changed how information was spread and created the birth of many newspapers and magazines, which is where most people read the work of Dickens and Faraday. In our time, we have the internet, and especially the long-form videos on YouTube. There's so much wonderful information that one can glean off this site. But there's also a lot of low-level scammers and confusing things and misinformation. So in honor of Faraday, I'm going to start a series of videos on how to detect pseudoscience from real science. And that is going to happen next time on the Lightning Tamers. Now this is usually where I ask you to subscribe and hit like and make a comment, and all of that would be lovely. But I want to ask a little bit more because I think it's important. If you were inspired by this video, could you look for another video about Faraday from me or from anyone else that you like and promote that video on social media? Or find a quote about Faraday that inspires you, and you guessed it, promote that quote on social media. I particularly like this one. No matter what you look at, if you look at it closely enough, you are involved in the entire universe. Or get extra creative and recreate one of Faraday's experiments with a kid and post it on social media. Or make a cake, or a sandcastle, or a painting, or knit a figure that looks like Faraday and promote it. You get the picture. See, I've been asking around, and so many people are terrified of physics, mostly because of the math. And I feel like if we could promote Faraday, who was so beautiful with no math, maybe we could get a few people over their fears so they can start thinking for themselves. Personally, I love the mathematics, but that doesn't mean I want to learn everything from mathematics. And for those with math phobias, it really hinders their ability to understand the world and make informed decisions. If you think it's impossible, I'd like to refer to an 1847 letter that Faraday wrote Maxwell, where he asked if all mathematical scientists could explain their discoveries in common language as fully, clearly, and definitively as in mathematical formula. Now, Faraday thought it could be done because he had learned it that way from Maxwell. He said, Maxwell could convey to me a perfectly clear idea of your conclusions, neither above nor below the truth, and so clear in character that I can think and work from them. If you are a mathematical engineer or physicist, I think you owe it to the world to at least try. After all, if Maxwell could explain it to Faraday, you can explain it to your teenagers or on the internet or to your mom or to your brother. At least try to fight pseudoscience with real science. If you look at my over 100 videos, I have several with a lot of mathematics, but I always try to keep in mind those viewers without the mathematical so that they can still understand the story and where it came from. We've improved education before. I don't think people realize how dark even basic education was in the 1800s. Try reading Nicholas Nickleby or Oliver Twist or Jane Eyre to give a glimpse of the cruelty that the English inflicted on their own children, especially the poor and handicapped. But then Faraday lit a candle, and with the help of Dickens and hundreds of other education reformers, they made early education into a beautiful and wonderful thing. Why can't we do the same thing for advanced physics and chemistry education too? So I have an extra request for all of you. Find a candle and light it with your family and or friends. Take a moment with your flickering light against the darkness to philosophize. What is happening and why? This may seem like a trifling thing to do, but as Faraday said, even the trifling act can add up and create a torrent of knowledge and change the face of a country. Faraday said in the introduction to his series on the candle, which is beautifully recreated and modernized for free on YouTube by engineering guy Bill Hammack, quote, "There's no more open door by which you can enter the study of natural philosophy than by considering the physical phenomena of a candle." Okay, thanks to my patrons, and as usual, stay safe and curious, my friends. Goodbye.